Hello everyone, my name is Diane Marret. I am our Sustainability Director for Consumer Packaging North America. First, I'll just start off with a little bit about what's my more. So my more is I want more recycling because I want to minimize the amount of waste that is in our environment. It's a fairly simple idea, but a lot of complex solutions. So excited to share that with you today and look forward to hearing more about your more. All right, so today's conversation is circular materials. So just to start us off with, Berry has made some big commitments in this space of circular material. We have a commitment of using 30% circular plastics by 2030. And really the purpose of this is not just our own internal growth, but to support our growing customers' packaging sustainability goals. And this all goes back to the beginning with the consumer. Consumers are looking for solutions to the global problem of plastic waste. And we acknowledge we are a part of that plastic waste problem, and so from our perspective, we're working to understand the right kind of materials that we can introduce to address that. So those consumers, when they have concerns, they're looking to brand owners to help come up with feasible solutions. Brand owners in turn are coming to people like Berry to help them identify the right options to support their plastic packaging goals. So first, we want to increase the use of recycled plastics. We want to increase the use of renewable plastics and ultimately reduce CO2 emissions as innovation is driving that further growth in those circular resins. Berry's made some big commitments in this space to purchase those materials, up to 1 billion pounds of circular resin into the fast-moving consumer goods space by 2030. So let's start off with mechanical recycling. Mechanical recycling, or post-consumer resin as you hear it referred to, PCR, is materials that have been collected through curbside collection primarily. They go to a local recycling facility where they get separated into the different polymer bale streams. Those bales get purchased by a reprocessor who takes that material and does a really simple shred, wash, and repelletize. So utilizing those materials back can get a little bit tricky. And so first, let's just talk about the different streams that exist. PET. So PET bottles are the ones that are probably the highest well-known use of PCR. There's a lot of significant efforts to keep PET bottles as a really clean stream. So removing any color contaminants, removing any additives. These types of materials are ideal for food and beverage applications, spirits applications, even personal care. High-density polyethylene. This is an area where we've got two different options. The colored bottle stream is targeted for non-food contact. Those are coming primarily from things like laundry detergent or shampoo bottles. So these type of applications are ideal for industrial or personal care space. The natural bottle stream is coming from milk jugs. So that milk jug stream is targeted specifically for anywhere that you've got food contact or specific color matching requirements. These are ideal for that personal care space, containers, bottles, anywhere where you've got food contact requirements. And then lastly, polypropylene. Polypropylene is one of the harder PCR materials to source, especially when it comes to food contact. There are options that are available for non-food contact. There are some options that are available for food contact, but they're a bit more limited in availability. So where we see this working really well is in some of the personal care space and in some limited food applications. So just one of the things to keep in mind with mechanical recycling is that while these materials are definitely suitable for a lot of different applications, there are some challenges when it comes to quality and aesthetics. So that's why we look at what's coming next. So we've got these areas that are in development and starting to gain some traction now: bio-based materials and advanced recycled materials. So let's start off with bio-based renewable materials. These are materials that are coming from renewable feedstocks, things like sugarcane waste or palm oil or waste cooking oils. Some of these are very separate physical material streams. Some are mass balance allocated as well. So it's a mix in this area. Biopolyethylene is available today and is in use. Biopolypropylene has been predominantly used in Europe, but is starting to get some domestic traction in North America. And PET-30 has been around for a number of years, not widely used, but another alternative. What makes these materials attractive is that they are recyclable. And ultimately, these are the types of materials that offer the greatest carbon footprint improvement. So if you're targeting net zero goals, these are a great type of material stream to look at. So just as an example here, Braskem green PE coming from sugarcane. This type of material has a significant carbon footprint improvement versus virgin resin, and is definitely something to target in areas where you've got net zero goals, carbon footprint improvement goals. Compostable materials. This is an area I like to mention. We don't spend a lot of time on these types of materials, but they certainly are something that have a lot of growing interest. So these would be unique materials you'll hear like PHA, PLA, cellulose acetate. There's certainly a lot of others that are in development space right now, but these are the main players. Right now with these types of materials, they are a bit limited in what types of products you can make and what types of performance capabilities you can achieve with them. Currently there's two different avenues for composting, whether it's industrial composting or backyard home compostability. There's definitely a limited number of industrial composting facilities available, and so that is an area that is definitely a target of interest, but until that number of composting facilities becomes more accessible to the general public, we are limited in what we can do with that material. At home or backyard compostable is definitely desirable, and we hear quite a bit of activity and interest in this space. We do note that the claims for these materials must be really clear and accurate and actionable in order to avoid risk creating any consumer confusion. One thing to note with most of these materials is they are not recyclable, and they can be a contaminant into the recycling stream. So this is why we are cautious about introducing these types of materials until we have the right type of infrastructure to support them. And just note that development timelines for these are typically fairly long, and right now they're very limited to specific opportunities. We see a lot of interest in this space, and certainly it'll play its role long term, but right now we're fairly limited to those unique opportunities. So moving into that advanced recycling space, recycling technologies beyond typical mechanical recycling, this is where these type of technologies come into play. So mechanical recycling works really, really well in areas where you've got clean streams of material coming in that don't require a lot of cleaning to break them down so that they can be reused. This is why PET bottles fit really well into this space. The issue is our plastic waste typically is a lot more complex than that. There's more contamination that needs to be dealt with. And so this is where we look to introduce other types of recycling technologies to address the bulk of our plastic waste. So the two that we'll focus on here today are purification and the feedstock or molecular recycling space. So one thing I'll note here is that these type of technologies are definitely complementary to each other. Mechanical recycling has a great place in our infrastructure, and it fits well with certain material streams, and that should be the focus long term. Advanced recycling will help us address the rest of our plastic waste and get us to a point where we have significant amounts of circular materials to introduce back into our products. So one area where we've implemented advanced recycling technologies is in our food service space. So we've been looking for the right kinds of partnerships to move some of these early adoption space of advanced recycling forward. And Wendy's is a partner of ours that was looking for solutions to incorporate recycled content into their products. We were able to align the Wendy's desire with material coming from LyondellBasell to introduce 20% mass balance allocated recycled material into Wendy's drink cups. This was a collaboration that's been in the making for several years, and we're excited that this is now into production. And just in this early stage, we anticipate we'll divert about 10 million pounds of waste from landfills just over the first 2 years of the program. So we recognize that we have to have the right players and the right partners coming together to make all of this work well together long term. So, where are you on your sustainability journey? Well, typically where we want to start is what is in your current portfolio that may be what we could consider low-hanging fruit. Something like maybe a non-food contact application, or something where you've got a product that the aesthetics aren't quite as critical. Where can we start, even if it's a very small starting point? And then potentially maybe some of these longer term sustainable materials are desirable, like the bio-based or advanced materials. Those may have the opportunity to fit within a specific portion of your portfolio. That may be the best way to start. And then just a general question about what are the threats that exist in the current portfolio. We know that packaging is under a lot of pressure to improve, and so what can we do to help address your strategy to get the right types of materials into your products? And then lastly, again, we want to know what's your more. I shared a little bit about what my more is, but please tell us what your more is. We're curious to hear and we want to learn from that. So thank you for your time today.